Welcome to the Grid Mod Pod, brought to you by AEIC. In this podcast, you'll hear from the utility industry's top operations leaders on how their companies are working to modernize and improve our ever-evolving power grid. Thanks for joining us.
Welcome back to the Grid Mod Pod, where we unravel the fascinating world of grid modernization. So I'm your host, Dr. Elizabeth Cook, and I'm thrilled to have you join us today, our esteemed guest. We have Tom Martin, who is the Vice President of eSource in the Commercialization Group. Tom, why don't you take a moment to kind of introduce who you are and where you're coming from?
Thanks for having me, Elizabeth. So, Tom Martin, I lead data science across eSource. eSource does a lot across consulting, research and advisory, technology implementation, and then my primary focus area is within our data science group. I've spent more than a decade in the utility industry, primarily focused on grid mod. How do we use new technology to drive changes across our industry? Before joining eSource, I was at PG&E, leading our emerging grid technology team. So that was everything from smart meters to line sensors to DERMS. And then where I now focus most of my attention, data science, primarily for the distribution grid, but also with several projects and initiatives focused on transmission as well.
Yeah, and so for any of those that have been listening to the Grid Mod Pod and or the season 1 All Things DER, something about me and that I'm passionate about is data analytics and really the power that the data holds, especially the data that us in the electric utility industry have not really taken advantage of. So I'm very excited to have the opportunity to talk to you and kind of explore the world of how the data analytics and the capabilities that we're finding really month to month, even not day to day, when you identify new ways of thinking, kind of creates a lot of capabilities that we've really haven't explored before. So I look forward to jumping in and just kind of sharing some of your perspective and experience that you've seen, as you've been helping utilities in the grid modernization space. So you kind of mentioned in your introduction, but really, how do you see data science from your perspective change how we manage the grid, and what technologies are important for us to really think about on the utility space to ensure that we can tap into that?
I think one of the step changes that we're seeing in the industry is not that data science is going to just totally upend how we think about distributing electrons to our customers. We've been managing a grid very well and very efficiently with the tools that we had. But in the same way that email changed the way that we communicate, didn't invent communication, but changed the way we communicate, now we have more data, we have more data processing capability, and on top of that, we're having new and innovative data science algorithms and models and approaches and concepts. And when you combine all of those, it allows us to do things differently, to do things better in a way that creates efficiencies for the grid. A lot of what we've had to do to manage the grid as best possible, given the data that we've had, has been to use time-based assumptions, cadence-based assumptions, or some sort of broad brush stroke peanut butter spread assumption, because we didn't have the ability.
I say peanut butter spread. Did I get it from you or did you get it from me? I don't know.
A little bit of both, hopefully.
Yeah. We're in the same space. Yeah.
Yeah. Right. So take something like, as we're starting to see this high penetration of distributed energy resources, we'll give a little throwback to season 1. Yeah. What the way we've modeled the grid before has been really efficient at understanding loading at the substation, and then makes those peanut butter spread assumptions of what's going to happen downstream based on some seasonal engineering studies, maybe some AMI data, but it's all very much kind of broad brush stroke assumptions of what's happening in real time or near-term future downstream of the substation. Now we have data coming from smart meters. We have data science processing that can essentially build a bottom-up forecast algorithm that allows people to get more efficient. That can mean more efficient switching operations. That can mean if you have an outage, you can be predicting what we always called it ghost load was, that the hidden load that was maybe coming from DERs that you weren't seeing. All of that just means it's a more efficient grid. It doesn't mean we're totally upending how we've managed our system for decades, but it means we can make more informed decisions, which create efficiencies from a cost standpoint and an operations standpoint and a reliability standpoint.
And I think, one thing I would, truly want to share and kind of continue the thread of like thought is, this idea that to embrace, or the requirements to embrace, or even really to step into the idea of data at the edge, it's not new data, right? Like, we as utilities, quite frankly, we knew about the watts and the VARs and the voltage at our breakers and even some of our intelligence switches. And with those that have deployed AMI, we then could see the voltage all the way to the edge of the grid. And I think that's like a missing aha moment for the everyday user of the power grid, is that like the job of the utility is to maintain voltage from the moment it leaves the substation, which is like your circuit breaker box in your basement of your house, how you rewire your house throughout the breakers, but all the way down to the edge, which is what you're talking about, to maintain good quality power for that safe, reliable, affordable power is a solid voltage. So for a utility to understand what that voltage is allows them to enhance and ensure that that continues to thrive. And so I think there's like a lot of thought, like this is new data and we're creating new needs, and like our grid is not as, smart, and now it's getting smarter, but it's really just having that instance of information allows the threading of the health of the whole system just to be easier. So like that's like the baseline performance, right? And so I think a lot of people miss the boat on embracing data analytics because they don't see distributed energy resources becoming a part of the grid in the near future. Therefore, it's not worth the investment. So just thinking about your experience, because I think we both came from the realm of planning and really understanding how like the circuits are individual fingerprints, right? Every circuit in every utility is dynamically designed different, and then it's used different. So why not have the capabilities to study it dynamically, right? And that's really what we're trying to talk about when we touch the edge of the grid and start doing that bottoms up that you spoke of. So like, what are some compelling case studies that like you've seen, kind of come to fruition to really help drive energy efficiency and solid power quality for the utilities that started to use, some of these new tools?
Yeah, absolutely. So we're working with a utility, a neighbor of yours, PPL, and they've spoken about this in a couple of articles and newsletters, but they were having issues, reliability issues, performance issues with one of their regions, their Northeast region. And they wanted to understand, how can we make investments that are going to move the needle? How can we make investments that are going to drive benefit for our customers and get the most bang for the buck on every dollar that we're putting into the grid? So they took a data science approach. The team over there has been very data driven for a number of years. And they said, what can the data tell us about how to be predictive? And what they uncovered was, yes, that area was having some reliability challenges, but the things that were causing some of those reliability challenges were not necessarily the investments that they had been making. Take an oversimplified example. If you have two identical circuits, all else being equal, except that one of those circuits is much longer than the other, you're going to expect that longer circuit to have more outages, has more opportunity for outages, has more exposure to outages. But that doesn't mean you should disproportionately invest in that longer circuit, because you wouldn't expect the dollars you're spending to have a higher lift, because the things that are causing that worse reliability relative to the shorter circuit is length, and that's not something that you're likely going to be changing. unless you're totally rebuilding your system. So the idea is, how do you use data to be predictive about what changes you can invest in? And so we're seeing a number of utilities on that front, and that can. The cool thing about once you build that data science approach is it creates a foundation on top of which you can run lots of different use cases. So you can look holistically across reliability, across all my reliability programs, or I can take that same foundation of data and drive into veg management or wood pole inspections or undergrounding. And I can be just as data driven with kind of a targeted lens on. And no longer do these reliability initiatives have to live in a silo, but they can all be connected, because at the end of the day, reliability is reliability, and an outage is an outage from the customer's perspective. And it doesn't matter if it's a veg outage or a wildlife outage or an underground failure. All of these could be mitigated. And how do I spend dollars to make sure that my mitigations are going as far as possible?
Right, and kind of tying that together, from my experience, being in charge of circuit reliability and looking at the system performance, right? If you only have static data, so historical data, and, just for our listeners, some of the most common reasons that the lights go out is for trees that we all love. Is pretty much number one if you're a very highly vegetated state or live within that area. The next is, quite frankly, it's maybe like depends on where it is motor vehicle accidents, hitting poles, taking out wires. Then there's the equipment failure as well as wildlife, right? So I think a lot of our listeners don't realize like a significant amount of reason why your lights go out is out of control of the utility. But what you're saying is taking all those uncontrollable variables and studying the placement of where they occur and using other threads of information that is typically not available to a utility's like fingertips, start to tell a story. And that story then creates the predictability that this area, yes, there's a lot of trees, but like maybe there's a certain terrain, maybe there's certain wildlife that runs through it, maybe there's like a bird migration. Like you really don't really know, and still you look at it from a bigger vocal point. And that's kind of the use cases that you're speaking of, and quite powerful. So you could spend identical circuits like $10 million and see no improvement, but then see significant improvement. And it could be due to those exterior databases that once were never brought in. And so that's I think so exciting. And I think we don't talk enough about, because you actually learn by doing. And so that's the big thing about data analytics is you're teaching beautiful mathematical equations like in statistical analyses from reoccurring repetitive data that then continues to like inform itself. So yeah, I think that great use case there. I would say, from an involvement of, management of, say, like you talked about predictive, right? So I think that's usually like the next word we hear is like predictive replacements, right? Or like O&M plans. Like, do you have any use cases where you can share where that was like kind of a part of, what the data told in regards to informing certain kind of O&M plans?
Yeah, absolutely. So there's two key elements here. One is, what can the data science tell us? And then two is, what can we actually do to take action on it? And I think where a lot of people in our industry get a little apprehensive is, oh, so I'm going to do this data science project and it's going to tell me that this thing is going to stop working tomorrow and I better go fix it immediately. I don't have the processes to handle that sort of information flow. And that's a totally valid reason for not spending money on a data science project. But the flip side of that is you can actually use the data science to solve the problem in a way that is as actionable and implementable as possible. If we take an example of vegetation, as you mentioned, it's one of the top outages. What we aren't going to try and do is predict, hey, this individual tree limb is going to cause an outage next week. You better go trim it. And then all of a sudden you're just blindly driving around your system trying to play catch up. That wouldn't work from a change management standpoint. That wouldn't be efficient in terms of how tree trimming gets done in the field. But what you can do is say, listen, here are the processes that we follow and how we get the best bang for the buck in terms of deploying vegetation trimming resources. Let's use the data science to direct them over a 1 year period, over a 3 year period, to the areas where they're going to have the highest lift, where they're going to deliver the best ROI from the work that they're doing. And so vegetation management is a prime example. We're not trying to predict tomorrow's tree trim failure, but we're trying to say, listen, if you're only going to get to one circuit, it should be this one, not this. If you have the money to get to 5 times as many circuits, here are the 5 that you should do, and here are the ones that you should postpone until later, because these have a higher risk than this. To kind of tie it to a very well-known predictive data science use case outside of our industry, it's Moneyball. I'm trying to say, which batters should I put in my lineup that are going to give me the most wins, the most hits, the best possible outcome. I'm not trying to say, let me predict on any one pitch whether or not someone is going to hit the ball, because that's an impossible task, and it doesn't do you any good based on how you're going to you can't change your lineup like that. You can't implement action based on that insight. So the same thing applies to our industry. We can optimize around the problem that's worth solving and using data science to do that.
So I'm going to kind of lead the witness here, only from experience. One thing about our industry being that as old as it is, if you think about how the grid evolved from what it is today, from where it came from, is a phenomena and kind of a preliminary design that was stood up, like the technology and the aha moments from over like 100 years ago. And we've scaled and we've grown the largest machine in the world. And we've been managing and maintaining these grids throughout that time. We had this beautiful growth period from really the 1920s to like the 1970s, 80s. And then suddenly we all realized maybe we should use less energy, and a phenomenon called energy efficiency came into our worlds. And we had this very large grid built out. I could talk history all day. So my point is, in the age of all of the assets that we're all maintaining as an industry, the records and the data and how that information was kept and logged has been on a journey itself. So something about our infrastructure data, not just electric utilities, but really all of these systems that have been created over the last century, there's something idea about disparagable or maybe dirty data, or like not the right data or not the perfect data. And so from your experience working with, the electric utility industry, how have you been able to see an evolution of realizing that you don't have to have the perfect data, you just have to have the idea and then some data, and then it can grow from there? Is that something that you've been familiar with?
Yeah,
Not from experience or
100%.
anything.
Yeah. My old boss used to say, all data is good until it's used. Whether data is perfect or imperfect, you're going to find out as you start using it. And the corollary to that is all data is bad until it starts being used. So if you're not
Love it.
using the data, it's never going to tell you anything. The approach that we use from data science is you've got to bring not only models and algorithms and processes that have been built and baked and tried and tested, but you also have to bring agility and flexibility. And so one of the approaches that we've seen be really successful for utilities in this space is combine lots of different data sources together, essentially to create kind of what I'll call a chain link fence. And so what I mean by that is, if any one data source does or doesn't have perfect data, and let's be honest, none of them have perfect data, but there's lots of other links holding that fence together and allowing you to still be predictive and still get value from that use case.
So you would say that that's pretty much the journey that you take with every utility that you embark upon.
Yes.
um,
Every utility has some amount of imperfect data. You hear a lot of times people who are apprehensive and say, well, and first what we need to do is do this big 5-year data IT centralized process before we can take action on the data. If you do that, do you know the business value that you're getting on day one after that 5-year journey? It's zero. Because if you're not using the data to improve a business process, to improve where you're deploying capital, to improve how you're using O&M to improve reliability, if you're not making decisions based on the data, it doesn't matter if it's perfect or it's totally non-existent. What you should be doing is focusing on what are the use cases that leverage data that I feel more comfortable with than others, and then let me slowly work in more and more data sources that I now am willing to trust. This can be baby stepped, one use case at a time.
Yeah, I love it. I was going to ask, kind of wrapping up here because I think you and I could talk forever. However, some days I think I could talk forever with anyone. No, but a lesson learned, and I think I'll just share maybe just your perspective is, we work within an industry where the designs, the standards, the specification has been really formalized and concrete, and we have a significant amount of regulatory oversight and just very programmatic type thinking, because this is how we've always done it. This is how it works. And really, from a generational thinking perspective, I think we're shifting, like into this reality that, I believe your imagination is the reality of the dreamer, right? And so you don't really get that from like the typical engineer, right? Like they're very taught to 1 + 1 = 2, and here's your theory and here's your formula. And I think in the data analytics space, which is quite mathematical as well as engineering in itself perspective, is allowing that openness within a utility space, right? And within that is like, it is the unknown, as you just said. You can't have that 5-year plan. You have to really start small. And so another thing we like to do is boil the ocean or eat the elephant. So just from your perspective, like, those small bites, I think you mentioned that, right? Like, what's one quick win that you recall that was kind of a fond memory that you can share with our listeners? So maybe that'll plant a seed that they can start a fire within.
So I was working with a utility that was really focused on how do we save money for our customers, and not just we've been allocated these amounts, so we're going to spend these exact amounts, but how do we drive change to be more efficient? And one of the things that they looked at is in our lower income areas, we are spending a huge amount of money on tree trimming. It's always in the backyard behind fences. The builders, the developers in these areas haven't invested in undergrounding themselves. But what if we were able to strategically underground in areas where it's actually going to be cheaper? And this is a little bit of kind of a we always in the industry assume undergrounding is more expensive than overhead, but if you start looking at cost of vegetation, having to do tree trimming behind fences in backyards over a multi-year period, all of a sudden that equation starts to flip, and you say there are areas, not everywhere, but there are selective areas where I can underground. I can save my customers money over a 5-year period. And the win for the utility is I can deploy capital to reduce O&M, and everyone wins. That's an area that is kind of a new way of thinking, to say, let me look over a multi-year period what I would spend in a different bucket. Tree trimming is not the same bucket as undergrounding. And I think we've always, to your engineering mindset, 1 + 1 = 2. The way we've operated for a number of years is like, once dollars are allocated to a certain bucket, they never move in
Right.
between buckets, right? But if we take a step back and say, we can never spend as much money as it would take to eliminate all risk, all outages from the system. We operate a grid that's going to have some amount of outages. With that fundamental assumption, what I need to be saying is every dollar I spend, I want to make sure it's reducing the most number of outages, it's doing the most amount of good for my system, for my customers. And maybe those buckets aren't the right allocation, and I should be shifting, I should be moving. And so this utility actually not only answered the question of where should we be doing this, but then because they had taken a data-driven approach, they were able to put that in front of regulators, in front of third-party stakeholders, and get buy-in to this process by being data-driven, not only internally, but by being data-driven, they were able to have a transparent conversation around why this was the best investment for everyone.
Well, I have to say, I'm so excited that I asked that question because I'm going to take it and I'm going to run with it, because that is, it seems like a very obvious thing after you say it, but that's profoundly a very different way of thinking, which is what I think is so exciting about, embracing data science and really the understanding thereof, of how we can think about data differently and unsilo all of those thinking paths and start, tying it all together and driving forward, driving out costs. So very, very happy they shared that story, Tom. So with that, I just wanted to wrap up and say thank you so much for your time. And I can look forward to continue this journey with you as we, find other use cases and really drive it through the organizations across our country. So
that's a wrap for this week's episode of the Grid Mod Pod. Thanks for tuning in. We hope today's conversation got you thinking about new and creative ways to improve our power grid. Be sure to subscribe to our YouTube channel to be the first to hear new episodes. This podcast is brought to you by AEIC, the place where operations leaders come together to share knowledge and provide guidance to the electric utility industry. We'll be back with a new episode soon. Until then, keep powering on.